Hi, it's Rob Farley here. I want to talk to you for a couple of minutes about a feature in SQL Server called a prox count distinct. Now, the thing with a prox count distinct is that if you're counting how many different values you've got, and you've got a lot of them, the way that you need to do it to be able to get the exact number is to keep track of the ones you've already seen. Now, if you've got sorted data, it's much less of a problem because you can just go through looking for changes. But way too often, data like this is not sorted. And so you end up having to create a hash table, which is just huge, to try and see, well, have I counted this one or not yet? And the effort to try and count a billion different values is often way heavier than you need to. You get spilling, you get poor performance, it just becomes a problem. And frustratingly, a lot of customers seem to want to do this way more often than they should. So Microsoft came up with this thing called a prox count distinct, where they discovered that some PhD students somewhere had worked out that this was a pretty good method of doing it, and I think it's remarkable. I want to explain to you why. And by explaining to you why I think this is good, it's, I think, enough to be able to convince you that it's a valid way of doing it, and that you should be able to consider it for those customers of yours who want to be able to count a very large number of distinct values. Now, the principle works like this. If we consider that we're applying a hash function to something, we get some value, and I'm going to say that that value appears on a line of the possible values that we could have. So you imagine there's some value, and we apply a function to it, and that value lands on this line somewhere. We have a different value, and this lands somewhere else, right? So in this scenario where we say, well, if we have, say, 4 different values across this, and we just go, let's assume that they're just kind of placed at random. If we say how far in from the left is the first value, on average, it's going to be a quarter of the way in, because we've got 4 values. That's where it's going to end up on average. It won't be perfect. It's not going to be exactly that. It just won't. But on average, if we do this enough times across enough blocks, it'll be pretty close. So the idea is, well, if we only if we split our hash address range into lots of these, and then we say how close to here is one of our values, and how close to here have we got, and how close to here have we got, and how close to here, because across all of them, if we reckon that the average, and this is actually a harmonic mean because it works better for this type of thing, if we see on average how close we get in this block and in this block and in this block, and how close each of those is getting to the line, then we'd stand a pretty good chance of figuring out roughly how many different values we've got. And when I say roughly, I mean 98% of the time getting within 2%. And I think that that's typically good enough. As a consultant, good enough is, well, it's good enough. It's good enough in query plans. It's good enough means good enough. If I'm going to say that I've got like 1.1 billion different values, I'll write that up here. 1.1 billion different values, that's probably close enough, as opposed to, say, 1.2 billion. They're not going to care. They want to know roughly how many there are. And if I'm within 2%, that's pretty good. Anyway, I've been Rob Farley. This is just really me playing around with the idea of drawing on the screen like this. I hope you like it.